Hello and welcome to a new session on basic statistics for data analysis in Python. I hope you guys have enjoyed our previous session on pandas in Python. So now let's move to some basic stuff. Statistics is a science of collecting, analyzing, interpreting, presenting and organizing data. And now let's move to some basic data types. They are qualitative and quantitative. Qualitative data measures the types, number codes, or we can say relative aspects, and basically they are non-numeric data. Quantitative data deals with numeric data types. Okay, and in quantitative data we can have two different types of series. They are discrete and continuous. For example, if I know that there are 10 students who have got 5 marks, 20 students who have got 20 marks, 30 students who have got 25 marks, that's an example for discrete series. And continuous series, I know that there are 10 students who have got marks in a range of like 10 to 20, and 25 students have got marks in a range of 20 to 30, and there are 30 students in a range of 30 to 40. We can say that it's a continuous series. So in both these series there are frequency distributions. Nominal, ordinal, interval and ratio are different scales of measurement. Nominal scale deals with non-numeric data. For example, states, occupation and sex of a specific individual. And this can be coded in numbers, but these numeric values don't make any sense for calculating the average. When we come to ordinal scale, values have a meaningful order in this, or we can say there's a specific ranking. But it also considers qualitative data like size, grades or ranks. When we come to interval scale, it has a specific order, but quantitative data is measured like temperature, calendar dates, etc. The ratio scale is the most precise one. It has a clear-cut definition for 0. Examples are length of different cloth items, numbers or counts, monetary values, etc. When we come to discrete and continuous attributes, both these are considered or concerned with quantitative data. Like if you want to give the example like profession or the number of people in a particular profession, zip codes or a set of words in a collection of documents, we use discrete attributes, basically whole numbers. Floating point numbers are not accepted, but in continuous attribute mostly real numbers can be considered as attribute values like temperature, height or weight, and these are basically floating point variables. Okay, now let's move to different types of statistics, and they are descriptive and inferential. In descriptive statistics, it takes data from a sample you are interested in, and we are not trying to infer anything regarding the population. For example, test scores of a group of students, and we want to analyze something regarding people who are in income bracket of 5 lakh, 10 lakh, we use descriptive statistics. And the common tools that we use for descriptive statistics are measures of central tendency like mean, median or mode, and measures of dispersion like range, standard deviation, and we use skewness for that. And when we come to inferential statistics, we want to make some inference about the population from a particular sample. So in this case we use inferential statistics, and the common methodologies that we use in inferential statistics are hypothesis testing and regression analysis. Once we are done with types of statistics, let's move to measures of central tendency and measures of dispersion. In measures of central tendency, we will be discussing mean, median and mode, and when it comes to dispersion, we will be discussing range, standard deviation and variance. Skewness and kurtosis will give you an idea about the shape of the distribution. Mean is a central value of a series, and median is the middlemost item of a series. Mode is the most frequently occurred item in a series. In this case, median is the or we can say that it's a positional average, or if the data series is there, we need to arrange the data in either ascending or descending order before finding out the value of median, because it's a positional average. Position matters a lot. When it comes to dispersion, dispersion is nothing but it would give you the spread of the distribution. For example, when we talk about range, range will give you the difference between the maximum and minimum value of a series. For example, if the minimum value of a series is 10 and the maximum value is 70, the range is 70 minus 10, that is 60. Standard deviation tells you the spread of the data, or we can say how much it is stretched. For example, if there is a data series with 10, 11, 12, 11, 10, we can say that it is a tight series, or the values are much closer. And we can consider another series like 10, 20, 45, 75 and 95. We can say that it is more stretched. And we can find the value of standard deviation using the formula square root of x minus x bar whole square divided by n. And we can discuss more about that when we come to examples in MS Excel and Jupyter Notebook. Variance is nothing but the square of standard deviation. And when it comes to skewness and kurtosis, it will give you the shape of the distribution. For example, if the distribution is not normal, we can say that it is shifted to the right hand side or left hand side. Then we can say that there is skewness, or the normality of the distribution is disturbed. Kurtosis will give you an idea about the peakedness of the distribution, or we can say that how sharp is distribution or how flat is the distribution. Kurtosis will tell you more about that. And measures of dispersion and skewness and all when we come to MS Excel for more examples. Now let's see how to calculate the values of mean, median and mode in MS Excel. And I am using a simple example over here. These are the runs scored by the famous batsman Sachin Tendulkar in the past 10 matches. And I want to see the average or the mean, median and mode of the series. First, let me try with the mean score, and I'll use the function average for that. So let's see that. And the score is 79.9. I can use the same series for calculating median and mode. First, let me copy these values, and let's see the value of median by using the function median. And the value of median is 84, and I can see the value of mode also. And the value of mode is 85. So now the three averages are visible, and the values are 79.9, 84 and 85. And you can see that the values of median and mode are close to each other, but the value of arithmetic mean is quite different. And I can say that, or I would like to say that the value of median is the most trusted average, because that divides the series in two equal parts, and mode is the most frequently occurred item, because 85 has occurred twice over here. That's why 85 got selected as a mode. In a normally distributed series, mean, median and mode would be equal. I can show you how a normally distributed series would look like. So let me try that in Paint. It would be like a bell-shaped curve. Okay. In this case, the values of mean, median and mode are equal. So we would discuss this concept later. We have seen the three averages over here, that is arithmetic mean, median and mode. Suppose there are 3 or 4 batsmen, and we want to see which batsman is the most consistent one among the 3 or 4 batsmen we have considered. How to find that? Suppose the average can be same. It's quite possible. Let's see one example. So in this example, there are 3 batsmen. They are Sachin, Ponting and Lara. So these are the runs scored by these 3 batsmen in the past 10 matches. Now let's see the sum. And you can see that the sum of scores are the same. So obviously the arithmetic mean would be same. So how to find the most consistent one? Let's try this average value, and you can see that the average is same, 79.9. So how to find the most consistent one? For that we use the function standard deviation. We use a standard we use the sample standard deviation for that. And let's try this. And you can see the standard deviations of these three batsmen. Sachin's standard deviation is 15.41 and Ponting 15.87 and Lara 12.09. And from this we would conclude that the batsman with the less standard deviation, or you can say that the least standard deviation, can be considered as the most consistent one, because that series is not very much stretched. And you can say that Lara is the most consistent batsman among these three because he has got the least value, that is 12.09, and he is consistent throughout the 10 matches. Both these batsmen, Sachin and Ponting, because the standard deviation is more compared to the third batsman. Okay, when I say consistent or less stretched, you can say that the series is quite tight. The values are almost close to each other, and in the first two cases the values are not too close to each other. The values are quite different in all the matches. He might score, or the batsman X might score 40 runs in the first match, 80 runs in the second match, and 120 in the third match, but he would go for 2 runs in the fourth match and so on. But when it comes to Lara, it is almost consistent, like 20 in the first match, 22 in the second match, 23 in the third match, and 20 in the fourth match, almost like that. Okay, so that's the concept of standard deviation. Now we have the values of standard deviation of samples in front of us. We can also calculate the population standard deviation, and we use the function stdev.p for that. Let's find out that. So here it is 14.625 for Sachin, and let's copy these values to other cells, and you can see that there's a slight difference in these values. It is not wise just to limit the scope of standard deviation within Excel. So let's go to the conventional formula. What does it actually mean, or what does standard deviation actually mean? Standard deviation measures the average deviation of each item from its arithmetic mean. So let's go back to the paint. So deviation of each item from its mean. So here I am considering the population mean, and population mean, mu represents the population mean, xi minus mu. So xi means each item in the series, and standard deviation measures the average deviation of each item from its mean, population. Okay, so for calculating the average I am using n, and let's understand this first. So x minus mean. Okay, so let's find that. d5 minus the mean value 79.9, and let's log that value by pressing function F4, and the deviation is minus 29.9. so let's find the deviation for all the items in that series, and we need to take the summation of that. For that, sigma xi minus mu by n. Now let's formulate that formula. Sum you can see that the value is 0, so xi minus mean will always be 0. So how to find the deviation? For that, we need to square all the values. Okay, and let's find the square of this. And that's the squared value. Now we can see a value over there, that is 2138.90. Now that's not the original value. Okay, and to go back to the original value, so here we have the square because we have squared it, and when we want to go back to the original value, we need to find the square root. Okay, so this is the original formula of standard deviation. So let's do that. So equal to SQRT function for square root divided by 10 is the number of items. Okay, that is 14.625. Here it is, it's the same value. So when we understand the concept, I think it's better to understand in this way. So standard deviation is nothing but the average deviation of items from its arithmetic mean. So it can be population mean or sample mean. Okay, so whatever be the mean, it can be population or sample. You need to understand the concept in a better way. In a nutshell, standard deviation gives you the spread of the data, and when we want to see the average square deviations, we use the term variance in statistics. So these two terms, standard deviation and variance, are considered as very important terms in statistics, and without this we cannot move ahead. And now we need to see the symbol to represent population standard deviation, and sigma is the symbol that we use to represent population standard deviation, and this is a symbol. And when it comes to variance, it is sigma square, and that's it. So till now we have dealt with mean, median, mode, standard deviation and variance. And now let's come to quartiles. So this should have done along with median, but I think this is a apt time to do this because it needs some more explanation. So I thought I would take it to the end. Now let's understand quartiles. So Q1, Q2, Q3 are the quartiles, and Q4 is the maximum value of that series. Okay, quartiles divide a particular series into 4 equal parts. So Q1 means suppose the value of Q1 is 40, it means 25% of the values in that series lie below Q1 and 75% of the values lie above Q1. Q2 is nothing but median. We have already explained what's a median. And Q3 means 75% of the values in the series lie below Q3 and 25% of the values lie above Q3. Okay, and we need to find out what are these particular values. Okay. So let's try with the first series, and we are moving ahead with the same series. The runs scored by 3 batsmen, Sachin, Ponding and Lara, and different matches. I have just included some more matches, and now the total matches are 20. Okay, now let's see how to find out the values of quartiles in MS Excel, and then we need to go ahead with interquartile range and outliers, and we need to create a box plot graph for that. So let's try with Q1, Q2 and Q3 first. For that I need to use the function quartile.inc. I need to select the array first, and here I am you can see that there are 4 values like 1, 2, 3 and 4. If I press 1, it would be for Q1, so I need to find the value of Q1, and let me log these cells because I need to use the same set of cells for Q2 and Q3 also. So press function F4, value is 67, and I need to change these values like 2 for Q2 or median, 3 for third quartile or Q3. Let me press 4 for the maximum value. Okay. Now you can see that the maximum value of the first series is such a maximum value of that series is 101. And the value of Q1 is 67, Q2 is 83, and Q3 is 93. What does it mean? So the value of Q1 is 67. That means 25% of the items in the series are below that value of 67, and 75% of the items are above the value of 67. Okay. Value of Q2 is 83, and that's the value which divides the series into two equal parts. And the value of Q3 is 93. It means 75% of the items are below 93 and 25% of the items are above the value of 93. And 101 is the maximum value of the series. Okay. I think you have understood the concept of Q1, Q2 and Q3. I hope you guys are okay till now, and I have added the minimum value 2 to find the range of a particular series. So range is the difference between the maximum and minimum values. Maximum minus minimum. So these are the respective values. And the next one is interquartile range. Interquartile range, the difference between Q3 and Q1. So Q3 minus Q1, we'll get the IQR. So these are the respective values. IQR is important in quartiles because if we need to find the outliers, we need to have the value of IQR with us. So the next step is we need to decide the upper and lower cutoffs, and for that we need to multiply the value of IQR with 1.5. I'll explain the concept. The next step is we need to find the upper and lower cutoff. So let's write as UCT and LCT. Now we need to decide the upper cutoff. For that, the value of upper cutoff can be decided in this way: 93 plus 38. That's the value of upper cutoff. 93 plus 38. And for lower cutoff, Q1, that is 67 minus 38. So these are the respective values. And the meaning is that any value beyond the upper cutoff and lower cutoff can be considered as an outlier or as an extreme value. So we can find these extreme values when we plot a graph, a box and whisker plot. So once we have the graph with us, we can see the outliers. So let's go ahead with that. Now we can go ahead with the box and whisker plot, and for that we need to select the data first, then move to insert statistic chart, box and whisker. So let me explain this chart first. You can see the upper and lower whisker. The upper whisker shows the maximum value and the lower whisker shows the minimum value. So they are 101 and 45 respectively. The upper boundary of the rectangle shows the value of Q3 and the lower boundary shows Q1, and the middle portion, this line shows the value of Q2 or median. Okay, and now let's talk about outliers. Outliers are extreme values in the series. So suppose if I change the value of 85 to 140, you can see a dot over here. So this can be considered as an outlier. If I change the value to 3, you can see a dot over here. This can also be considered as an outlier because this is much beyond the upper cutoff and lower cutoff regions. I mean, this 140 and 3 are much beyond the upper cutoff and lower cutoff regions. So this can be termed as an outlier. Okay. I hope you guys have understood the concept of outliers, and in this session we have discussed mean, median, mode, standard deviation, and quartiles. And in the coming session, we will be dealing with all these functions in Jupyter Notebook. I hope you guys have understood the concept very well. Thank you.